Example 12. A park ranger driving on a backcountry road suddenly sees a deer frozen in his headlights. The ranger, who is driving at 11.4 meters per second, immediately applies the brakes and slows with an acceleration of 3.8 meters per second square. If the deer is 20 meters from the ranger's vehicle, when the brakes are applied, how close does the ranger come to hitting the deer? Okay, so let's try and draw a car. Mana boleh masuk hutan ni kereta ni? Tapi boleh lah. So, permulaan dia drive. Lepas tu dia brake. Dia brake sebab dia ada nampak deer. Boleh lah tu, deer. Time tu dia brake tu, dia punya distance is 20 meter. Okay? Silap, not here. The 20 meter is from their brake. Okay, so ini them dia assuming it's here lah when they apply brake tu di sini. Okay, so they nampak the deer 20 meters before. Okay, and then we have to find the distance after dia tekan brake tu, how close dia dekat dengan the deer. Okay, so now we can use the formula v square u square plus 2as. So why did I not use v equal to u plus at? Why am I not using this as well as this? Because the time is not given. So if the time is not given, why would we use that, right? Okay, now just substitute. We know that v is equal to, assuming the car moves from rest, so 0 square, u is 11.4 square. I'm sorry, I forgot to always try to extract the information. Okay, so we know that u is equal to 0, and then we have the not u equal to 0. The velocity, initial velocity, is 11.4 meter per second, right? But when they apply the brake, the velocity would equal to 0. Lepas tu ada acceleration been given, which is 3.8 meter per second square. Okay. Dia cakap slows with an acceleration, applies the brake. Maksud dia negative. It is decelerating. Okay. So plus 2, negative 3.8. I hope the car tidak dengar sampai this video. It's really loud. Okay, so the displacement in which how close the ranger comes to hitting the deer is 17.1 meter. Okay, so the distance is then, I'll level it as x. The distance between the stopped vehicle and the deer after they apply brake is 20 minus 17.1, which is equal to 2.9 meter. Okay, so now we have to find the time needed for the vehicle to stop. Now we can use the formula vu plus at. Okay, so 0, 11.4 plus negative 3.8 t. Rearrange that and calculate. You'll then get 3 seconds for the needed for the ranger vehicle to stop before hitting the deer lah. Kalau lebih dari itu, nanti dia hit the deer, mati lah itu deer. Okay, so that is example 12.